I'm Emma,
I'm Daniela.
and our background behind the physics of the elevator has to do with Newton's first law. Newton's first law states when an object is in motion, it stays in motion unless acted upon by another object. So an elevator, when it's going up, it keeps going in the up direction motion until another force is acted upon it and then it stops. When you're going down, then that when it comes to a final stop after being in motion, it has to do with Newton's third law, because when Newton's third law is when it stops, our body wants to keep going down, but the force of the elevator is stop, so it's pushing us up. So then we stop.
And our hypothesis is that when I take my weight, when we're just at the ground and at rest, is going to be less than when I take my weight going up on the elevator, and that when I'm going up on the elevator, my weight's going to increase.
Daniela's original weight is 120. Daniela's
Getting on the elevator to take our medicine. Okay, now we're going up the elevator. 125.8. So the equation we're going to use is F equals ma. And to find F, we're going to take the difference in our weight versus the regular weight. So the first weight was 120 when we were at rest, and then going up the elevator, my weight was 126. So in order to find F, we have to find, it has to be in newtons, so 1 pound equals 4.448 newtons. And we're going to take the difference of these two numbers, which is 6 pounds, times 4.448 newtons, and that number is 26.88 newtons. So our force for this, in order to find the acceleration of the elevator, which is what we're trying to find, is going to be 26.88 newtons.
Okay, so in this equation now, since we already found force, now we're going to be finding mass to get the acceleration of the elevator. So what you're going to do to that is you're going to take your weight at rest, so I'm taking 120 pounds, and I'm going to multiply that by 4.448 newtons, and this was how many newtons per pound. And then from there I get 533.79 newtons. Then you're going to divide by 9.8 because gravity is involved when you're going up the elevator, and your final mass is going to be 54.46 kilograms. Okay, so we're still using this same equation, force equals mass times acceleration, but now we're finding acceleration because we know force and the mass. So we're going to take the force, which is 26.88, and we're going to equal that to our mass, which is 54.46 times acceleration. Then what you're going to do is you're going to divide 54.46 from both sides, and your final acceleration when you divide the two is going to be 0.49 meters per second squared.
Hi, I am Mariah Sexy, and I am the third member of this group along with Daniela and Emma. So for the conclusion part of this experiment, just to recap kind of how we found our final answer, we used the equation F equals ma. And like shown in the analysis and calculations, we found that the force equaled 26.88 newtons. We also found that the mass equaled 54.46 kilograms. And using the F equals ma equation, we ended up finding that the acceleration of the elevator going up with Danielle on the scale equaled 0.49 meters per second squared. Therefore, our final answer is acceleration equals 0.49 meters per second squared, which is the acceleration of the elevator while Daniela was on the scale going up. Okay, so now for a brief explanation and a little bit of a recap. So Emma and Daniela already described how this experiment relates to Newton's first and third law, but it also relates to Newton's second law as well. I'm sure most have, when you're in an elevator, you jump right before it hits the bottom because for that split moment you feel weightless. But this is actually can be explained by Newton's second law. This is Newton's second law and applies to the second law because if you're accelerating up on an elevator, you oftentimes feel heavier, and when you're accelerating down, you feel lighter. Therefore, it is said that if the elevator cable broke when you're going down, you would ultimately feel weightless because you and the elevator would both be accelerating down at the same rate. Okay, so now to go a little bit more in depth about Newton's second law and how it pertains to this experiment. So Newton's second law pertains to behavior of objects, which all existed forces are not balanced, so it's important to know that they are unbalanced. And the second law states that acceleration is dependent on two different variables, and these variables are the mass of the objects and the net force on the object, or is oftentimes written as F net. So through the second law, we can find that acceleration depends directly on net force, but it depends inversely on the mass. And we can also say that as the force is increased, acceleration increases as well, but as the mass is increased, the acceleration is decreased. Okay, so that wraps up our elevator experiment, and we hope that our explanations, calculations, and just the whole experiment helps you understand the physics involved with going up an elevator. Thank you.
Thank you.